go through number 6, which says determine the length. So the moment I get to I'm saying number 6, okay? I'm still having my formulas. Remember, the formulas there for, so they're my friends, okay? Nothing to think. They say determine the length. So L, I'm looking for L. And they're saying the resistance, R, is going to be 2.00 ohms at 20 degrees. So T is 20 degrees. If I'll need it, I'll know. If the wire's cross-sectional area, so that means I don't really need the T, okay? So if the wire's cross-sectional area, we can just put it somewhere. I mean, T is 20 degrees Celsius. They said if the wire's cross-sectional area is going to be 3.31 times 10 to the power of negative 6 square meters, okay? And they want the length of the copper wire. So what do you see? Well, you just look at this. You have L, you have whatever. So you just go to the formulas, and you look for the formula which helps you to find the length. Now, there are only 2 formulas with length. I have one which is for drift velocity. Then I have the other one which is for resistance here, resistance and resistivity. And it's obviously the one I'm going to use because I have resistance, I have area. So I can just come here and say that resistance is equal to rho L over A. I'm doing this with a pencil first, okay? Because I'll have to check and make sure I have everything in this formula, but that's the formula I'm going to use. So now, I'm looking for length, L. So do I have A? Yes. Do I have rho, the resistivity? No. But do I have R? Yes, I have R. So now, what is it that I need to get? I will need to know the resistivity for my number 6. I would need to know the resistivity of copper, okay? So what is that going to be now? Now, this one, the resistivity of copper at 20 degrees also happens to be a constant, which is 1.7 times 10 to the negative 8 ohm meters, okay? This is another thing to know about copper. So far, we have seen 2 things which we may want to put for copper. One was, let me put it like this. We can say the resistivity is 1.7 times 10 to the negative 8 ohm meters. That's the first thing, resistivity at 20 degrees Celsius. Then the other thing which was like the density, okay, which we saw like this, and we saw that it was 8.96 times 10 to the power of 3 kilogram per cubic meter. So if I know these 2 things, then this is at 20 degrees Celsius, okay? At 20 degrees Celsius. If I know these 2 things, then I'll be fine, okay? This is going to be the density of copper and the resistivity. 1.7 times 10 to the negative 8, 8.96 times 10 to the positive 3. Oh my goodness, I'm going to remind you at the end again so that you don't remember, you don't forget. Now we're going to say we need to find the length. So it's going to be R, it's going to be resistivity is, R is there. Resistivity was multiplying the length. So when it comes here, it's going to divide. Then the area was dividing. So when it comes here, it's going to multiply. So it's R times A over resistivity. This gives us the L, which is going to be 2.00 ohms times the area, which is 3.31 times 10 to the negative 6 square meters, divided by rho, which is 1.7 times 10 to the negative 8 ohm meters. This will give me the length. You just put in the calculator, time to punch. So 2.00 times 3.31 exponent negative 6. I get an answer, I say divided by 1.7 exp negative 8. Then what am I going to get now as my final solution? I'm just going to get my L, and it is going to be 390, okay? And this is 390 meters, and this is going to be my L. And I am done. Here is my final solution, and that's how easy it is. No thinking, nothing. You just put the things down, then you look for the formula which goes on with this, and you would be done.